Friends, welcome to this class. Before going to this electrophilic ring opening reaction of this epoxide or the oxiranes, let us see one more reaction, that is nucleophilic ring opening reaction using Grignard reagent. Right. So see, Grignard reagent means R minus will be there, because of which it acts as a nucleophile. Right. So what happens? See, here because of this magnesium, it will form bond MgX. So oxygen gets positive charge. So it has ability to break the bond. So where it will break, whether it will break like this or like this, it will break like this only. Why it will break? Because here this carbocation is formed. Let me write that. To this carbon CH is there, and here CH2O MgX. This carbon is formed. Right. So why only here the bond breaks? The reason is here there is pi bond. Right. It will stabilize this charge, right? So how resonatically it will stabilize. So these are the two stabilizing structure. So it becomes double bond here, again form CH, here it will be CH2 and it will be OMgX, right? And here carbocation, primary carbocation is formed, right? Like this rearrangement can happen, right? So stabilization of carbocation occurs. Again this pi bond will be broken and this carbon gets positive charge, right? So R minus will be there, right? Grignard reagent, nucleophile. It can attack to this carbon also, or it can attack to this carbon also, right? So we will get both the product. I hope you will write. Simply remove that positive charge and make a bond. Similarly here, remove that positive charge and make a simple bond, right? So it will be neutralization. So this is all about nucleophilic ring opening reaction, right? I hope you understood it. Next, let us see this electrophilic ring opening reaction, right? So this one, electrophilic ring opening reaction. So electrophile will attack. Till now what we are keeping, we were keeping this constant because we are studying the reaction of this epoxide, right? Initially we studied about nucleophile like ammonia I took, secondary amines I took, hydride I took, like R minus, H minus, sorry, not R minus. It is nothing but LiAlH4, right? And Grignard reagent R minus I took. All these were nucleophile. Now I have to see this electrophile. For example, if I add HCl to this epoxide, HCl in water medium. So HCl means H plus will be there, Cl minus will be there, right? So what happens? See, since this is a symmetrical, first H plus will attack to this lone pair and I will get this one. So oxygen will be having positive charge and Cl minus is there. Since it is symmetrical, it can attack here also, no problem, right? So I will get this product, Cl here and OH here, right? So this is nothing but electrophilic ring opening reaction, right? Yeah, but here also nucleophile is attacking, but here they have considered it to be electrophilic ring opening only, because first electrophile will be reacting to this lone pair, because of which they might be considered, right? So let me see one more example. Here also R is there, here also R. To this I will add compound like acyl chloride. This is called acyl chloride, right? So what happens here? Lone pair is there. So this carbon will be electrophilic. Why it is electrophilic? See here, because this halogen is a electron withdrawing group, right? So electron density will be taken by this, and here also double bonded O. It also acts as electron withdrawing group. If it takes the resonance, you will see that it will be like O minus and H plus. So it acts as electrophile. I hope you know. If you see this COR, stretching frequency of this mu CO stretching frequency, if you see, it will be around 1780 per centimeter, right? So this indicates that greater the stretching frequency, it means there will be electron withdrawing group here, because of which this carbon will be more electrophilic, right? So this carbon is more electrophilic. So this having lone pair, so it acts as nucleophile and attacks to this electrophilic carbon. So what I will do, I will get this compound. See here, R here, O minus, one more CH3 is there, and here chlorine is there, right? Since chlorine is a good electron and this gets positive charge, right? Oxygen, because it has donated its lone pair of electron, right? So what happened? See here, it will break the bond and it becomes neutral. let me write here. Let me rub all those things. I hope you have noted it down. Along with me, you keep writing so that it will be easy for you. Right. So next, let me write the product. So what I'll get? I'll get this one. This carbon gets positive charge. Here R is there as usual, and here O, CH2, methyl, Cl. Right. O minus. Right. O minus. I hope the same. No. They did differently. So what they have done is simply see this. Let us see how they have done is like this. Right. Till this, I think you got it. Right. So as soon as this electron density comes here, this chlorine is a good leaving group. I left this point. I should remove this chlorine as a Cl minus. So what happens here? Other things remains as it is. Here positive charge is there, and here O, CO, CH3. CH3 is as usual, and Cl minus is there in the solution. That Cl minus and this positive react, and they will form a simple bond. Right. So let me show that. So I will get this product. Right. So this is the product. Initially only I should have shown it, but I forgot. Right. I hope you got it. So how I should show is that here oxygen is there, right? So here I have taken this one, COCl. As soon as its electron density gives, it takes the electron density again, it gives back to this carbon, and chlorine leaves the system. So what happened? R. So this will be like oxygen donates the lone pair, double bond O, CH3, and this gets positive charge, and Cl minus will be there, right? So this Cl minus attacks this carbon, and ring opening takes place, and I'll get this product only. See, check it whether I'll get the same. Yeah, I hope you got it, right? So these were the electrophilic ring opening reaction. Let us see one more, that is other ring opening reaction, or we can call it as miscellaneous ring opening reactions, right? So this example let me take so that it will be interesting to you. So here this is epoxide. Everywhere I'll take this epoxide only, because we are studying the chemical reaction of epoxide only. To this I will add this SnCl2. So it acts as simply catalyst, and I will add one aldehyde. It is PHCOH. So aldehyde, this electron will be electrophilic. That thing also we know, right? So what happens here? It acts as nucleophile. So here like this reaction can occur. Right. I hope you are getting. So what happens is that, see, simply R, and here O, this O minus happened pH. If chlorine is there here, then it will come again back, and chlorine will be leaving, because chlorine is a good leaving group. But here no, here chlorine is not there, hydrogen is there, and phenyl group is there, right? And here this bond is there, right? As soon as it donates, it will be like epoxide here, plus bond will be there. So what it will do, it will take the electron density and becomes neutral, because oxygen can't have negative charge, so plus charge will be here. So this plus and oxygen minus, they can react like this. So they will form a 5-membered ring like this. O here, and other things as usual, R, and here also R. Here R, it is not R, it is pH phenyl group. Let me write it, pH phenyl, right? So I got 5-membered ring, and the name of this is dioxolanes. So this compound I will get. It is a 5-membered ring, right? I hope you got it, how it happened. Just you see it slowly, you will get to know, right? So these are the miscellaneous reactions of this this epoxide, or the oxiranes we call, right? Let us see last reaction, that is thermal reaction of this oxiranes. So thermal reaction, what we do in that, let us see that, right? So this is thermal reaction. Right. So what are the, here what I will do, I will add PR3 and I will heat it, right? Heating condition, thermal reaction. So it also comes in other or miscellaneous ring opening reaction of this epoxide. So what happens here, from this lone pair it will be donated to this carbon, and this bond will be broken, right? So what happened, I can show like this, P R3, as it donates its lone pair, phosphor gets positive charge, and here O minus is there, right? And here R will be there, R, and here H. You can show, if you assume that R is above, just you show it above, and H you make it below, because stereochemistry also matters here. And here also R let me take above, and this H let me take below, right? So if I rotate this 180 degree, only this carbon, this stereochemistry I will keep same, this carbon, only this carbon. If I rotate 180 degree, why I will rotate? Because phosphor oxygen bond will be very strong, right? So since here it is 180 degree, see both are 180 degree, both are anti, one is above, one is below, like this. So both are anti now, because of which it will be trans, no interaction will be there. But here positive charge, negative charge, little attraction, because of which it will rotate to 180 degree. How it will rotate? It will come above the plane, right? So here see, stereochemistry of this carbon will remain same. R will be above, hydrogen will be below. But as soon as this carbon rotates, stereochemistry, see, this oxygen now comes above, O minus. While coming, this will go behind. I hope you know the stereochemistry. If I rotate 180 degree, the above one comes below and below one comes above, right? So what happened? Here R was above, right? Now it comes below. And this hydrogen was below, now it comes above. If you, I have discussed this in stereochemistry, right? Basic stereochemistry, there also I have told you how it happens. So now oxygen is having negative charge, phosphor is having positive charge, so it will form bond like this. Further, we know that phosphor oxygen bond will be stronger than carbon oxygen bond, right? So phosphor oxygen bond will be stronger than carbon oxygen bond. So what happened? Simply it will take this oxygen, right? So how it will take? It will take, so here double bond is formed, this carbon gets positive charge and this bond will be broken, and again this carbon becomes neutral. So I will get alkene. What kind of alkene? I started with cis epoxide, because both are where same side, right? So I started with cis epoxide. Because of this rotation, I will get trans. See here, this R will be, see here, R will be below, this R will be above, means both are opposite side. So I will get trans, right? I hope you got it. From cis I started, but I got trans. The reason is this rotation. Why rotation occurs? Because phosphor oxygen bond is stronger. So it is same as Wittig reaction now. From here it is same as Wittig reaction. We got this alkene because this bond will be broken. I hope you know this thing all, because I can show directly, we will show like this. It is the correct method. For understanding purpose, you can break like this. Initially it gets negative charge, this gets positive charge, right? So what it will happen? It will give its electron density here. So double bond happens here. This electron density comes on carbon. So here negative charge. So negative positive, it will form bond and we can form this double bond. Like that also you can understand. But we directly show that arrow marks, right? For understanding, it's true. However, you can understand. But while writing, you need to write that arrow mark only, right? I hope you got it, how I rotated that. Similarly, if I start with this trans, one is above or one is below. So this is trans epoxide. To this, if I add PR3 and if I heat, I will get cis alkene. So stereochemistry, because of rotation, I have to do that. So how to do that, I will explain you, right? Just see here, like this. If they have given trans, just you write like this. One hydrogen will be below, one R will be above, right? Trans is there, so one more R will be below and one hydrogen will be above. This is the structure of trans. Trans meaning one is above, one R is below. If I want to make it cis, how I will do? See here, both I can make above, or both are, if I make below also no problem. Both are cis only, right? So this is cis. So after PPH3, if it attacks, then I will, what I will do? Just I will write like this. See here, O minus, and here PR3 plus. Phosphor bond has formed, right? So both are 180 degree. So there is no interaction, right? So what I will do? I have to rotate, right? During rotation, see, just I want to rotate. Whenever rotation happens, this above bond comes below and below bonds comes above. Only this bond I am rotating, this carbon I am keeping same. So stereochemistry you try to maintain same as it is, just you rotate it so that above bond becomes below, below bond becomes above, right? Other things remain same. So one thing, what are the tricks you remember? Just to keep this carbon and this oxygen in single plane, right? These arrow, simple arrow represents they are in same plane, and this is above and below. You deal with this R and H only. If you make this phosphor attacking above, this oxygen going below, it may get confused for you. So this is the simple method, right? You keep this carbon-carbon bond and carbon-oxygen bond in single plane. Just you play with these two things. Make R above. If both are R above, it will be cis. One above, one below, it will be trans. And you just rotate. You will get. If it is trans epoxide, you will get cis alkene. If it is cis epoxide, you will get trans alkene. I hope I concluded this. Yes, I explained it nicely for you. So this is the chemical properties of oxiranes. So I was doing video on computer. So many people told that it will be not affected as I am teaching on board, right? But see there, if I keep on, if you have patience, you watch that video till the end for one video for 30 minutes. If you watch, there you will feel it nicely, because I can show you everything there from lone pair how I will show. Because here what happens while writing, I have to see book. Sometimes I may skip seeing that reaction. Some reactions I may skip, but why in computer I can't. I will make it nicely. No, I will watch all those things, problems, and I will explain to you. So that will also be nice, right? So I will do. I won't leave this board method also. I will do both the things. Right, it will be helpful. The just one thing you have to do is you watch that completely computer video, so that it will be nice. Once you become familiar, 1-2 videos if you watch, then other things you will keep on getting, right? So this is about my oxiranes. In next class, let's just see one more compound.